Welcome. As a part of our machine design course, we are here to pitch a final project, which is a semi-automatic clothes folding machine. Considering our current scenario, almost everyone would be familiar with the most boring chore in a household and how frustrating it can be to fold clothes. So, Team DaCrease brings you some relief. Let's go ahead. Elaborating on the said problem, if this task of folding clothes could be automated, it would save a lot of time and energy. However, currently we do not have an effective and affordable solution at a household level. This motivated us to come up with a solution that could just as easily be implemented in houses and wouldn't need nothing more than just a power outlet. But first, let us have a look at the current market. Among all the machines that do the same or similar task, there's always a trade-off between cost and function. The simplest of designs don't make our lives any easier, and prices range from just 500 bucks to almost the cost of an iPhone. So after drawing inspiration from these aforementioned technological options, we present a simulation of the design we came up with. So we have designed a semi-automatic, affordable, and portable clothes foldable machine which operates just on electricity. Our machine requires the user to put the clothes onto a platform and take them off once it's folded. It consists of a central platform and three folding flaps. Each flap is activated by means of a custom cam mechanism powered by a motor to automate this process. Each flap has holes in them to prevent the formation of air layers and prevent sticking of clothes to this flap, which would have resulted in an improper fold. So, next step is to present a summary of the design process undertaken to develop a model. After having thoroughly deliberated on the need and using the current technologies, we found our own path and developed a CAD model and analyzed its form, function, and failure. So here is a blueprint of our CAD model. Alongside, we have also presented the SVAJ diagrams of the central cam, which is the heart of our model. Did you accidentally place something heavy on the platform? No problem at all. We recognized that the components most likely to fail would be the linkage system between the followers and the folding flaps. After having performed finite element analysis of these linkages, we found that even for unrealistic representative forces, none of the links was even close to yielding. And since practical loads are even less, we can all surely guarantee that the model has low to no chance of failing. From an economic and business point of view, we present some advantages our machines have over the current models. It, it's first of its kind to provide the middle ground we need between industries and consumer machines. The product is easy to manufacture since it's mechanical in nature, and its simplistic design is really cost effective, which saves money, which would have usually spent on resisting shocks and breakages. And even if there's any breakage at all in this mechanism, the parts are very easy to replace and repair, being mechanical in nature after all. So, who do we want to help? Primarily, we intend to target homemakers and bachelors, since these categories of people are most likely in need of such a product and will be benefited by the time and effort saved by it. So, how do we wish to proceed further? After some more testing and optimization, we can develop a prototype using 3D printing and laser cutting. Based on the reception of a model, we can push the product for mass production. And once the production kicks in, we believe that our solution can create a huge impact on the market as well as lives of many people. Thank you for your attention.